So, good day, everyone. Royal Grand Engineering Trainings Limited and Nigerian Society of Engineers Ikeja branch welcomes you to this training on ProtaStructure. So today is the day three of the 1 month free engineering software training on ProtaStructure, a training that was organized by Royal Grand Engineering Trainings Limited in partnership with Nigerian Society of Engineers Ikeja branch. So without any further ado, today we are going to be um, talking about analysis, design, and then our foundation. So that is what we are going to treat today. So the analysis process, today's session is not going to be that long because the analysis process does not take much time, as well as our designs and what we are going to do about that. Then, so we are going to first of all treat our pre-analysis and then treat materials and loadings, building analysis, finite element method, and displacement diagrams. Then we are going to go to our designs and interactive design checks. Then we are going to now go to our substructure, where we are going to design for a powered foundation. So, and after that, we are going to draw our conclusions and then talk about our assignment. So, here is our learning objectives for today. At the end of this session, every participant or student should be able to perform building analysis of ROC structure, perform interactive design of ROC members, and also design pad foundations. So, okay, here we have a pedestrian bridge that was modeled and successfully designed using the software ProtaStructure. And here as well, we have a small foot overhead bridge that is sitting on pile foundation, just like so. All this can actually be achieved in ProtaStructure. So we are going to be teaching a lot of things during our advanced classes. I would advise you to, you know, do whatever you can to be part of that our advanced classes. Okay. So without any further ado, let's jump straight into ProtaStructure. So we are right here on ProtaStructure. So this is where we are at. So this is basically what we have done in our previous classes. So we have treated modeling, we have treated loading, we have also treated how to create your axis and all that. So if you have done your assignment, like we have shared in our last class, this is exactly what you are going to have. What you are going to have is supposed to be looking just like this. So after your modeling, once you have finished the modeling of every single detail that you need for your building according to your architectural plan. So the next thing that you have to do is to perform analysis, to run analysis of your um building, to perform a building analysis. But before we do that, I just want to show us a few things that we should have known or we ought to know. That is our story settings. So many of us may not have known this because we didn't talk about that when we should. So this edit story option is basically used to edit the the height of your stories and the story properties of your model, the height of all that. So for most of us, the default story height is 3 meters. So if you have a different value of your height, so you can change that as well. So to do that, just simply go to your building setup tab, and here we have the story operations. Click on the drop down arrow, and then we have our edit story. Just simply click on that. So we are going to get the edit story option or dialog. So the first tab here is basically the story number or just the story. So here we have the height of each story. So my own says 3150. That is because I changed that to 3150 millimeters. So by default it's usually 3000 millimeters. So you can change that to any value of your choice. You can change that to 3600. It solely depends on what you have in your architectural drawings and that is basically what you're going to design for. So I choose my own to 3150 millimeters. You can leave your own as default 3000 millimeter, or you can change that to whatever you want. That is what we have here. So here is for the story one, we have our story two, and here we have story three. And in this next option, we have the reference, we have the level. So this is basically the reference level of your story from the ground floor. So this first story, the reference level from the ground floor is 3750 millimeters. So we also have 6900 for the second floor, and then 10 meters and 15 millimeters for the final roof level. So here is basically the label on each story. So here you have the option to change the label. So that label that you get when you see 1:1, 2:2, things like that. That's label that denotes the story. So here is where we have that. You can change that to any entity of your choice. It could be letters or it could be numbers. So let's just leave it as one for now. So here is the description. So you have the option to describe the story. You can write anything that you want there. It could be letters or anything. So it's basically not that important, it's just for description purposes. And here at the extreme end, we have the option to select the structural systems that is going to be used for that particular story. So here we have our RC, which means reinforced concrete. We also have the option to change that to steel if the members in that story are made up of steel. So let's leave it as RC, um, since it is made up of reinforced concrete members. So at this part of the screen, we have our foundation settings. This is basically where we set some things according to our foundations and how we would want that to look. So here where it says first story bottom level. So by default it's usually zero. It's usually zero. So you have the option to change that to any desired first story bottom level. So the first story bottom level is basically um the height of set of your first story. That is the ground floor, the bottom level of your first story, that is the ground floor, the height offsets of it from the ordinary ground level. So at the 00 level, that is your ordinary ground level. So the height offset of the ground floor level from that ground level, that is what we mean by your first story bottom level. And here we have it at 600 millimeters. That is why the reference level of this first story is 3750 millimeters, because by the time you add this first story and then this first story bottom level, you are going to be getting that value here, which says 3750 millimeters. So here we have our foundation depth. So this is basically self-explanatory. So that's the depth of foundation that you are going to be using um, for your um, for your design. So the foundation depth is just basically the depth of foundation downwards into the soil until you get to the bottom of your footing. So that is what we mean by your foundation depth. Mine is set as 2000 millimeters. So you have the option as well to set that to whatever you want. So here we have the effective top story number. So it's set to 2, it should be 3, but I set that to 2 just because our final level, which is our roof level, is not part of the effective number of story that we have. So we are basically designing for a two-story building. So that is that. So we also have here the imposed load reduction. So we have the option to apply that, and we also have the option to set our different stories as similar stories. So let's leave that unchecked for now, and then say okay. So when you have done that, your structure is going to update just like so to what you have set it to. And also notice on your structure tree the different reference levels of different heights is just stated here, just as shown in your structure tree. So having done that, let's jump straight into our analysis. So to start your analysis, simply go to the analysis tab. and then click on this option that says building analysis. So when we have done that, the first tab that we are going to get here is the pre-analysis tab, just like so, as you can see that. So in the pre-analysis tab, this is where the main assumptions of the analysis are made. So in design, it basically starts from assumptions, then we get to what we actually want. So this is where the first assumptions of the analysis are actually made. So we have the options to do some simple setting or minor settings. So just click on setting center, and the first is the code. So this code is basically the code that you are going to be using for your design. So you have the concrete design code, steel design code, loading code, wind load code, and earthquake codes as well. So click on the concrete design code. So it's now set to the United Kingdom Euro code. That is because we selected that code when we were now opening this project up. So now we have the option to change that to whatever you want. I don't want to do that because this is the code that we now use for our design of structures in Nigeria, the Euro code 2. So leave that as the for say cancel. So you also have the option to change the steel design code. So since we have not modeled any steel members, we are not going to go into that as well. We also have our loading code, wind code, and then earthquake code. If you are designing for buildings that are going to be subjected to earthquake loading for your seismic design purposes. So here we have your lateral drift and bracing. So this basically defines the bracing conditions of your beams and walls. So your members in direction one, that is your horizontal members, are going to be braced by your members running in direction two, and your members in direction two are now going to be braced by members running in direction one. That is the default setting. I would advise you to leave that just as set. So here it says sway amplification coefficients. So this will automatically be calculated after the analysis based on the sway classification of the structure. Now, if your structure is now classified as sway, the amplification factor will be greater than 1 here. Where you have the application factor, it will now be greater than 1 if your structure is classified as sway, and then all analysis method will automatically be amplified to that factor. So if you check this user defined, it gives you the option to amplify that factor manually. So I don't advise you to do that. Uncheck that so that the software or program will be able to select the best amplification factor. So you can say that if you actually know the amplification factor for your building. So here, go to units and formats, and then under displacement, change your meters to millimeters. My own is already set to millimeters, so you can change yours from meters to millimeters so that your displacement values will be shown in millimeters. So when you are finished doing that, simply close that. But before you do that, you can go to your project preferences. So here is where you set the some basic preferences that you would want for your project, like your title, the name of the client which you are working this building for, and the project title, the project number, address, and all that. So here, this is where you have to input the name of the person who calculated or designed the building, or the person that is presenting that, and all of that. So it's probably going to be your name. So you have the option to input that as well. So when you are done with that, that is the basic setting that we need for now. Simply say OK, and now go to your loading combinations. So we have already talked about this when we were modeling our slab. So this loading combinations are very, very essential in structural designs to account for simultaneous actions of multiple types of loadings. So this loading combination are actually used to ensure that the structure performs safely under the worst credible loading scenarios or the worst credible loading combinations. So this G simply means your dead load, and Q simply means your live loads. So here we have other loading combinations as well. NX, which means your notional loadings, and your P, which means your pattern live loads as well. So you can add any additional loadings if you want, but I don't advise you to do that unless you are absolutely sure what you are doing. So here we have the loading generator. So when you open up this, if yours is blank, so what you simply need to do is to go to the loading generator. So this loading generator automatically generates different loading combinations that are factored according to the design code that you are using. So if you are using the Euro code, there are different loading combinations that are actually factored together with that design code. So when you click on that loading generator, you are going to get this loading editor dialog. So, and the first you have to you have this option that says create different combinations of steel member design. We are not designing, we have not modded any steel members. We are going to leave that unchecked as well. And pretty much every other thing here, we have to leave that unchecked as well. So here we have your horizontal loading combination, and here we have your notional loadings. Notional loadings are basically imaginary load that are used for the sake of analysis. They additionally help to, you know, to account for different construction mistakes during the actual construction of the building. So they are actually added um, from the point of view as a factor of safety. So here we have the option to add your wind load. So we are not going to add wind loads for now because we may not have the necessary time to display all of that. So in our advanced classes, we are going to be talking about our wind loadings, how to add them, the conditions necessary for adding wind load. It's not all buildings that you are designing for that you have to, add the wind loading parameters for. So in our advanced classes, we are going to be explaining all of that. So when you are done with that, just simply say okay. So you are going to get this. If you have not already gotten that, then say okay. Say yes. So here in this part of the screen, we have your different materials and their properties. So we have our columns, we have the material property for the concrete, and here we have the reinforcement property. So this is the grade of concrete, and here is the grade of steel. So the grade of concrete we have here is the C28/35 grade, and for our shear walls is they are all pretty much the same thing. So if you want to change the grade of concrete and grade of steel that we have, simply go to this option that says edit material, this option right here that says edit material. Simply click on that once. So when you have clicked on that, you are going to get this option that says default materials and foundation floor materials. So your default materials are basically any settings you do here that are only going to apply for your superstructure. Every other members that are in your superstructure, and for the foundation floor, the settings that you do here will be only applied for materials that are going to be used for your foundation elements. So here say default materials, and let us change the grade of concrete if you want. So simply go to your columns, concrete columns, and then say click on the grade of concrete over there. So here we have different concrete grades. We have the 16/20, 20/25, and all the way down to 60/75. And by the right side of that, you are going to find the um, mechanical, physical properties of that particular grade of concrete, just like your modulus of elasticity. We have also as well your characteristic compressive strength of concrete, knowing that your concrete are actually compression members. So your concrete are actually very, very good in compression, better than your steel. So we can change that if we want. So let's say 20/25. Since our structure is just a two-story building, it is not that a massive structure. And here at the design parameters, we can see the compressive strength of that particular grade of concrete to be 20 newtons per millimeter square. So say okay, And let's do the same thing for our concrete walls. Select that. So since we want our the rest of our members to be some kind since we want our structure to be a monolithic structure, like a homogeneous structure. That is, we want every part or every members of the structure to be of the same material. It goes a long way to ensure the stability of the structure. So what we are going to do is that we are going to change the rest of the concrete grades for different members to be the same thing. That is probably our 20/25. Now click on that. So let's simply click on /20/25 so that we can have that as well. Now check this option that says apply to all members of this material class in this story. When you check that, every other members of your superstructure will get this particular grade of concrete and then say okay. So you can notice our concrete beams and our slabs here now have that particular grade of concrete. Now to change the grade of our steel, simply click on that. So we have here the different rebar grades as well, and by the right is the properties, just like your tensile strength of steel and all that. So we are going to leave it as 500 Newton as the grade of 500 grade, which is basically 5 500 Newton per millimeter squared, and then say okay. When you have now finished doing that, now go to your foundation floor. So you have the option to change the foundation property the properties that are going to be used for your foundation elements. So change the concrete grade. Let's leave it as 25/30, knowing that your foundation carries a lot, pretty much every load that comes from your building that comes into your building. So it's now rest on the foundation. So let's make the grade of the concrete for our foundation to be slightly bigger. So let's leave it as 25/30. And now let's say okay. And let's leave the grade of steel as 500 as well. So when you are done doing all this, make sure you say okay. So having done that, we are now done with our pre-analysis. So the next thing that we need to do is to go to our analysis tab. So in your analysis tab, you have the building model check option. So this building model check will check for possible modeling errors or mistake. So simply click on that. We have already done that. So this is the list of errors or possible mistakes that is going to check for. Click on start to start the building model check. So it's not going to take a lot of our time. Okay, so it says here building model check completed and the number of errors that we have is equal to 0. That basically means that we have not sustained, we have not incurred any errors or mistake during our modeling. Now, if it says number of error, if it says that you have any errors, now you now have to go back to your modeling and then find the place where you have made those mistakes and make sure you correct them before moving on to your analysis. Then when you're not done with that, simply say close. And before we go into our building analysis, here we have this option that says perform eigenvalue analysis. Now, an eigenvalue analysis can be performed as part of the building analysis for natural frequencies and mode shapes. So during the eigenvalue analysis, no load cases are actually used, but the eigenvalue analysis results can now be used for seismic design purposes. Is actually used for seismic design purposes if your building are going to be subjected to earthquake loadings and all that. So we have this option that says display analytical model before analysis. So if this option is checked, the analytical model will be produced and shown before the analysis of your members. So we have here another option that says refresh the connectivity information of all members. So to check if your member connectivity are updated before analysis. So leave that checked just like so. Here you have the final option that says save foundation column slash word result for multi-block combined foundation design. So this is only required when the project will be imported by another project for combined foundation design. So leave that unchecked as you have it there. Now simply go to your building analysis and click on that. So when you have done that, the building analysis is going to take some time. So but before that, we are going to get this option that says batch design option. So select the columns slash beams and then click on this to reselect the bar design. So what this basically does is it runs the design of your structure immediately after the analysis. So if I don't want to do that, I can simply uncheck that. But since I want to run the design of our structure simultaneously with the analysis, so I can just check that just like so. Then after that, you can now click on your building analysis. So the analysis process is going to take approximately 2 minutes to be completed. So I will advise you not to interrupt the process. Just patiently wait for it to be completed. So meanwhile, while we wait for that, I would like to confirm that everyone is following up. So please send in an emoji if you are following or if you are hearing me. Okay, thank you, Ekene and Samuel. So the analysis process have been completed, and what we are now experiencing is the column reinforcement design. Then after that, the beam design is going to follow suit, and before you know it, our design is going to be completed. So the design is now what is happening right now. So the column reinforcement design have also been completed, and now is the beam reinforcement design that is happening right now. Yeah, it is done. So our analysis and our design has now been successfully completed. So now we have a message here that says direction one relative story drift satisfy the limits, and for direction two as well. So simply say okay. And here our building analysis completed successfully. Total elapsed time says 2 minutes and 21 seconds. So that is very good as well. So our analysis and design was now completed in 2 minutes and 21 seconds successfully. So simply say close when that is done. So now we have now successfully finished our analysis. So we can go to our building analysis to view the post analysis method. Go there, say post analysis over here, or alternatively you can close that up and now go to your views tab and then open up the analytical model. Here we have the analytical model. Click on it once so that the analytical model of what we have now designed is going to be shown. So here is the analytical model of the of our building. So this is what it looks like. It's you can, you know, you can control it just like you can do for any 3D view. Use the zoom in and zoom out. Use your mouse wheel for your zooming in and zooming out, and also your right click to pan that as you would want. So the blue lines that you see here are basically your analytical model wireframe. These blue lines, and then we also have these red lines that are basically your displacement lines that are just for your displacement, that show the displacement of your members. And these darker blue lines we have here are basically the rigid beam of shear walls. You can see that. So that is very, very good. So we have the option to, turn off the displacement option diagrams of that. So we simply have here the analytical wireframe of that. So we can turn off or on the different stories that we want, so that we can view them the way we want them. So we are now looking at only the story one. We can also turn on the story two and then story three as well. So this is basically our analytical diagram. I mean our analytical model, just like so. So let's turn on everything here. So we have the diagrams here. You can check that. Now click on all these to look at the shear force and then the bending moment of each of them. So it's going to respond to this drawing as well. So here we have the displacement values for your shear forces and then your bending moments. So you can turn them on or off there just to interact with them as you would want. So go to your 3D view. You have the option to close your building model if you want. So let's close it so that our software can be running quickly enough. So now, after you have now finished doing that, the next thing that you have to check for is the design of your building, the design of your different members. Now, to do that, simply go to the design tab, click on that once, and then select columns in order to view the column design, and then your column and then your wall as well. So let's maximize that. So this is the column design phase. So this green tick mark simply means that our columns have all been well designed. You can see here we have the design status, and here we have the different levels of the columns. So scroll down to the very end so that you can see the walls as well. So the wall and columns are now designed at the same time. So here we have our one column 24 with this design status showing the red X, which simply means that this particular column has failed in design. So to correct that, simply click that and then double click, and then go to your interactive design so that you can have the interactive design window so that you can correct um the column. So when you have done that, simply wait for it. Um it's going to respond. So here we have the interactive design option. So simply say interactive design so that it's going to correct that. So it's giving us a warning, says steel bars cannot be selected, section size insufficient. So that simply means that you must increase the size of this particular column. So here we have the properties of your columns, and here we have a little bit of a detailed drawing of that particular column. So simply say increase the size, let's say 250 for instance. Let's say 250 by 250. Click on update and now say interactive design. So when you have done that, you are going to get this message that says reinforcement for H20, which simply means that um the design is now okay right now. Okay, all right. So when you have done that, simply say okay, and you are going to get that green tick mark, which means that the column has now successfully passed the design. So in our advanced classes, we are going to spend the time to go slowly, step by step, and explain every single thing that I have just done, and explore different ways of making sure that all your columns have passed the design. So I would advise you one more time to make sure you register for the advanced classes, so that you can upscale yourself in this structural design. Okay, so we have the reports here. So this is basically where you generate the reports. So if you want to generate a report your of all your columns design, you just click on this design report. It's going to be generated automatically. So here we have the steel bars. This steel bar simply tells you the provisions that we are made for those particular columns. So it says here 4 times 1 H16. This simply means 4 numbers of H16 bar. H16 simply means 16 of your reinforcement, and the letter here we have H means high yield strength of the 500 Newton per millimeter squared um, strength of reinforcement. So when you have that like so, that's basically all we need to check for our column design. So simply close that. So the same thing goes for your story beams. When you click on your story beams, the story beams design dialog is going to appear here. Let's maximize that. And here we have your story beams as well. So these are is the axes that are corresponding to that those every one of your beams. And here we have the rebar pattern, and here we have the design status as well. Your utilization ratio is here, and we have here an option to print the beams when you are now printing your beams. So that's basically what you need to know for now with regards to your beam design. So the same thing happens for your foundation beams as well, but we have not modeled any of that. Now to check the design status or a visual interrogation of your model, simply go to the display tab, go to the visual interrogation by the left side of your screen, and then scroll down. You're going to see this option that says design status. Click on it once, and then the design status of your building is going to be showing in the background. So this is basically what we have just done. So we have here the design status of your building, where red simply means that the member is failing, has already failed, and yellow means warning, and the orange color is for expired analysis. Green simply means that the member has now successfully passed the design. So you also have the blue color, which simply means that you should not design the member, and the white color for members that are not designed. So we have our slabs not designed. So in our advanced classes, we are going to be showing you how to perform your slab designs and how to run strips in your slab. So that is basically that about our design. So please, Engineer Henry, my colleague, is going to be dropping the attendance form on the chat box like right now. So please, Engineer Henry, please help me with the attendance form. Okay, someone is asking a question. How do we register for the advanced class? So we are going to talk about that in the group once we finish this call. So just contact the customer support, which is the rent customer support. You are going to be guided on what you need to do in order to register for the advanced class. Okay, thank you. So it's okay for our design status here. So we have this red color that says failure. Okay, how we went about that? We can simply go to your display tab. Here we have the visual interrogation by the left side of your screen. You have display settings, you have visual interrogation, you also have rotation center. So simply click visual interrogation. So when you have done that, by default, it's going to be set to none. So you have many visual interrogation that can now be used for your structure, for your model. So you have the option to choose the column sections, beam sections, wall thickness, and all that. So, but for now, say design status so that you can be able to see that. So the red, any member that is colored red simply means that that member has now already failed. So most of our members or all of our members have successfully passed the design. That is why um, we have that just like so. So is that clear? So that's very good. So the next thing on our agenda is our pad foundation design. So we are now going to move we are now going to move into our foundation substructure.
Hello, sir.
Yeah.
Can you hear me, Mr. Kingsley?
Yes. Yes.
Okay, I just did my check now. So all the members they are showing in what they because I added a share word, it's showing red.
Your share was colored red.
Yes, sir.
So it simply means that your share was have not passed the design. Do you understand that? So
Oh,
if you want to correct that way, there is a way that actually there are procedures that you actually follow to now correct that. So we are going to be discussing that
okay.
on Sunday. So on Sunday it's mainly for questions. So we are going to have a Q&A
Okay.
session on Sunday by 6:30 p.m. I will advise you, each and every one of you, to be there. Come with all kinds of questions. Okay. So we are going to be treating them during that time. Is that okay?
Okay, sir. Thank you.
Okay. It says here that our call is going to. You can now successfully mute yourself. So it says here that our call is going to be ended in 30 minutes. So with that, I'm simply going to close this call right now so that in our next call, we now have the option to we now go into our substructure and start um inserting our part footings. So the attendance form is going to be dropped in our next session, which is the second half of the session. So see you guys in 2 minutes. Thank you.